the topics we are going to deal with today. And in this lecture, what we are going to see is, we are going to see topics like hexadecimal number system, and we are also going to see how the hexadecimal number can be converted to decimal number. Also, we are going to see how a decimal number can be converted to hexadecimal number. So, also how we can convert a hexadecimal number to binary number and also binary to hexadecimal number. And we have already seen in the last lecture what binary number system means, but there is a drawback the binary number system has. The drawback is this: suppose we take a number like 255, say it is in decimal, in binary we write it as 11111111. See, this is how this number gets converted to a binary number, and you can see that 8 bits are required to describe this. Similarly, if we take another example like 1023, which is a decimal number, the binary equivalent comes out so long and 10 bits are required. Like this, if suppose we take another bigger number, more binary digits will be required. So, it will become difficult for a computer personnel to remember and also to write down the binary number, and that is the reason why nowadays we prefer hexadecimal number system. So, what is hexadecimal number system? In hexadecimal number system, we have 16 digits. The 16 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 10 is written as A, B, C, D, E and F. These are all hexadecimal numbers, and hexadecimal number has 16 digits. So, it has a base of 16 or radix of 16. Like binary number system, the radix is 2. So, and we know that 2 power 4 is 16. So, it follows that any hexadigit can be represented by a group of 4-bit binary sequence. In hexadecimal system, what we do is we represent each digit as a power of 16, and you can see that numbers and any number or any digit in a hexadecimal can be written like this in the powers of 16 power 1, 16 power 2, 16 power 3 etc. for the integer part, and for the fractional part we can write it as 16 power minus 1, 16 power minus 2, 16 power minus 3 etc. And these quantities which I have represented as 16 power 1, 16 power 2, 16 power 3, 16 power minus 1, 16 power minus 2 etc. can be called as the weights in hexadecimal system. Coming to how to convert hexadecimal to a decimal number. For conversion, what we can do is we can take the hexadecimal number, and for each digit we have to find the product of that digit and its weight. Likewise, for every digit that is written in the hexadecimal form, we have to take the product of that digit and its power or its weight, and then we should add up. So, that is what I mentioned here. As you can see, hexadecimal number can be converted into a decimal number by taking the sum. Sum means we have to add up. What we have to add up is the product of each digit and its column weight. So, what we mean by this? This we can understand from a simple example like this. I have taken a hexadecimal number, that is D5. So, how to convert this D5 to its equivalent decimal number? So, you can see here I can write this as D5. Okay. And now, what is this D5 actually? This is 16 power 0 and this is 16 power 1, as we did earlier in the binary number system. So, now what we have to do is first take this 5 and multiply this by 16 power 0. Then take D. What is D actually in hexadecimal? This is not D actually, this is a hexadecimal number D. We know that A stands for 10, B stands for 11, C stands for 12, and what? So, D stands for how much? 13. So, 13 into 16 power 1. So, that is what the D represents. It is a hexadecimal number D. Now, what does this give? This is 5 into 1, which is going to be equal to 5. So, this gives 13 into 16. What is 13 into 16? it is going to be 48 carry 4, and 16 in 16 plus 4 is 208. We will check again, what is 3 into 16? 48 carry 4, 16 ones are 16 and 4 will give us 208. If you add up this, you get 213. So, now you can see that this is hexadecimal number. What is it equivalent in decimal? It is 213 to the base 10. So, this is the answer that you get for this conversion. Let us take another example wherein I am taking the fractional part of a hexadecimal number. How to convert it into a decimal equivalent? Let us see that. For that, what we have to do is we have to write 0.82, and like we did earlier, this should be 16 power minus 1 and this should be 16 power minus 2. So, the answer for this will be 8 divided by 16, and this is 2 divided by 16 square. So, this should be 8 by 16 and this should be 2 by 256. So, that is what we should get, and this is going to be 0.5 because you know 8 by 16 is 1 by 2, and this will be how much? You will get 0.0. So, whenever we put a point, we get a 0 here. For this 0, we will get a 0. Then 200 also 256 will not go. So, one more 0 will come. So, in 2000 256 will go how many times? It will go 8 times, 8 48 carry 4, 4 carry 4, no, we can put 7. So, we get 7. So, 7 will be, you can divide and see, it will come within that, you may get a reminder. So, the answer now I can write it as, look at this, 0.8216 will be equal to 0.007, I mean 507, not 0.007, it will be 0.507 in decimal number system. This is what you will get. So, this is an hexadecimal number that is converted to a decimal number in this form 0.507. So, this is what you should understand. So, let us take another example, and in this example what we will do is we will take two numbers, we will take 82.56. Imagine this is a hexadecimal number, I want to convert it to a binary number. How to convert it? First convert 82 to decimal number, then convert this to the same decimal number like I did earlier. So, first take 82. So, what should be 2? Actually, there is 8 16 power 0. What is 8? It has a weight 16 power 1. So, now you can see it is 2 into 16 power 0 and this is 8 into 16 power 1, which will be 2 into 1 and this will be 8 into 16. How much will that be? This will give you 2 and this will give you 8 128. So, what you will be getting will be 130. Okay. So, 130 is the answer you will be getting for the integer part. Now, coming to the fractional part, it is 5 6. What is the weight of 6? It is 16 power minus 2. What is the weight of 5? It is 16 power minus 1. So, first take 5, it is 5 divided by 16, then take 6 and divide 16 by 16 power 2. So, you will be getting, we will take up the next sheet and try to calculate. See here, we will be getting 5 by 16 plus 6 by 256. How much will that be? This will give you 5 by 16 will be how much? Point. If you put a point, you can put a 0 here. This will go 3 times. So, you will get 48 and you will be getting 2. Okay. Now, this will go how many times? 256. You try to do 6 by 256 separately. Then you will be getting how much? Point. For a point you will get a 0. You put a 0, you will get a 0. 256 will go 600. How many times? It will go 2 times. If you put 2 here, you will get 12. You can put 2 here. 12 carry 1, 11, 5, 12. So, 600 minus 2, 1, 5. How much do you get here? 8. 9 will go 9. Again you get a 8. 88 you get 880. 880 this will go how many times? I think 3 times it will go. Now, if you add up these two, what do you get? You get 0.323. Okay. This is what you get for in the decimal equivalent. Earlier we had a number like this, right, and this is the number we are getting for D5. So, what is the answer we will get finally? We will get the answer as D5.323. So, this is the answer we will be getting for the problem we had taken. So, another example if you want we can take up, or we can go to the next one. Let us convert a decimal number to hexadecimal number. So, how to convert a decimal number to a hexadecimal number? So, let us see that now. Now, the number that I am going to take is 213, and let us see how this number can be converted to its decimal equivalent or hexadecimal equivalent. So, to convert from this decimal, so 213 is in decimal, and what we are trying to do is we are trying to get it in hexadecimal form. So, this is the base, this is how we represent the numbers. Now, to convert this, what we can do is in 21 16 goes 1 times, 53 it will go 3 times. So, you see 53 minus 48 should be 5. So, what we will be getting is 5 as remainder, and then we divide further by 16, we will get 0 and the remainder as 13, and we know as we did earlier this should be the most significant bit here and this should be the least significant bit. So, we should write the answer from here, and 13 in hexadecimal stands for D, because A is 10, B is 11, C is 12, D is 13. So, the answer for 21310 in hexadecimal will be D5. So, this is how we convert any decimal number to hexadecimal number, by dividing the decimal number and collecting all the remainders. We saw how an integer part of a decimal number can be converted to hexadecimal number. Now, here I have taken another example where we have both the integer part as well as the fractional part. So, let us see that number. I have taken a number like 98.625. This is a decimal number. Here we have both the integer part as well as the fractional part. Now, the integer part already you may be knowing how to convert it. We have to divide each of this number, that is 98 by 16, and we have to collect the remainder, again divide that whatever quotient we get again by 16 and collect the remainder. This is what we did there. And here what we are going to do is, for the fractional part, say for instance I have taken a number like 625. This is in the decimal number. I want to convert it to its equivalent hexadecimal number. Here what we will have to do is, I will have to multiply this number by 16 and collect the carries. So, see what I am going to do. First I will multiply 0.625 into 16. What do I get from this? I will be getting 0, because 16 nines are 80, I will get 8 here. I will get 40 because 16 twos are 32 and 8 will be 40, carry 4, and 16 6 are 96 and 4 will give me 100. So, you see what I am getting is 10 0 0 0 0. Okay. So, the carry here is 10. What is the hexadecimal equivalent of this 10? It is A. So, the answer for this 0.625, which is in the decimal form, will be point A in the hexadecimal number. So, this decimal number gets converted to hexadecimal as point A, because that is what we are getting as a carry. So, this is how we convert any fractional part of a decimal number to its hexadecimal equivalent. Now, we will take up another example. And let us take this example where I will change the number, I will change the number to 87.875, some number like this. Now, what we have to do is, first we have to take up 87 and convert it to its hexadecimal equivalent. For that we have to divide 87, 16 will go in 87 how many times? 5 times. So, we will get 5, that will be 80, and I will be getting a remainder of 7. If I divide further by 16, in 5 5 cannot be divided by 16. So, we will get the remainder as 5. So, 87, see the equivalent of 87 in hexadecimal is 57, okay, because this is the most significant bit and this is the least significant bit. Likewise, now I have to take this number 875 and multiply by 16. What do I get now? I will get 80, carry 8, and 7 16s are 112, 112 plus 8 will be again 120, carry 12, 128 plus 12 will be how much? 128 plus 12, it will be 140. Okay. So, I will get a 4, I will get a 0, you will get 140 and I will be getting 14 here. Okay. What is 14? So, I am getting a carry of 14, is it right? Then you see here, now I will have to take 0 0 0, that will not give us any problem. So, the answer what I am getting is 14. So, you can see A is 10, B is 11, C is 12, D is 13 and E is 14. So, 14 stands for E. So, what is the answer I will be getting for this? The answer for the number 87.875. See, I can write the number this way now, 875. This is in decimal. I want to convert it to hexadecimal. What is the answer I am getting? I am getting 57 point E. This is what I get in the hexadecimal number system. So, this is how we convert any decimal number to its equivalent hexadecimal number. So, this is what you should remember. Now, coming to the next one, let us go to the conversion of binary numbers. Now, so far we have seen how a decimal number can be converted to hexadecimal number, how a hexadecimal number can be converted to decimal number. Now, we are going to see how a hexadecimal number can be converted to its binary form. For this, what we have to do is, we have to replace every hexa digit with its equivalent 4-bit binary number. That is what we have to do. It is a very simple process. We have to take the number as it is, the hexadecimal number, and write the binary equivalent of it, and that is how we convert any hexadecimal number to its binary equivalent. To understand this, let us take an example. The example that I have taken here is D5, which is a hexadecimal number. All right. Now, this D5 I can write it as D5. See here, this is in hexadecimal form, and when I write the binary equivalent, what is the binary equivalent of 5? For that, you can determine 5 divided by 2. What do you get? You get a 2 here and you get a remainder as 1. Again, divide this 2 by 2. What do you get? You get a 1 and a 0. Again, divide this 1 by 2. You get a 0 and a 1. So, how do you write it? From the most significant bit, isn't it? This is the MSB and this is your least significant bit. So, how do you write this? You write it as 101, right? But this is not the correct way of writing the binary number when you are converting hexadecimal number to its binary equivalent. We have seen that we have to write 4 digits. So, how to write a 4 digit? I would like to put a 0 there. So, for 5 I can write the binary equivalent as 0101. Same way, let us take D now. What is D? D is nothing but A is 10, B is 11, C is 12 and D is 13. So, convert 13 to its binary equivalent. What do you get? You get 6 and remainder is 1. Again, divide the 6 by 2, you will get 3 and remainder is 0. You divide this by 2, you get 1 and a 1. Okay. Again, divide by 2, you will get 0 and a 1. So, your 13 is nothing but 1101. So, can you see this? This is the binary equivalent of this number. We can take another example. In this example, let us take another big number like E, F, C. All right. This is a hexadecimal number. How to write its binary equivalent now? So, again What is E? You should see for what is E. E is 14. Okay. So, 14 you convert it into its binary equivalent. What do you get? You get 7 here. Okay. You get a 7 and your remainder is 0. You divide again the 7 by 2, what do you get? You get 3 and remainder as 1, because in 7 you 2 3s are 6 and you get a remainder of 1. Again divide this by 2, you get a 1 and a 1. If you divide this by 2, you get a 0 and a 1. You write from here. So, the first number will be 1 1 1 0, is it right? So, this is what you get for E. Now, you have to write for F. F will be how much? 15, and 15 if you convert, see what you get? You get a 7 and a 1, and then again you divide, you get 3 and a 1. You divide this, you get 1 and a 1. You divide again, you get 0 and a 1. Again you write from here the most significant bit to the least significant bit. You can write it as 1 1 1 1. So, that is the binary equivalent of F. Now, what is C? A, B, C, it should be 12, right. So, 12 divided by 2, you get 6 and a 0. Again you divide by 2, you get 3 and a 0. You divide again, you get 1 and 1. You divide again, you get 0 and 1. So, what is the answer? You are getting 1 1 0 0. So, this is the binary equivalent of EFC, which is a hexadecimal number. All right. Now, having finished this, let us go to the next one. The next example, the next thing we are going to see is how we can convert a binary to a hexadecimal number. All right. Now, to convert a binary number to its hexadecimal number, what we have to do is we have to arrange the bits into groups of 4 bits starting from the LSB. Now, what do we mean by this? Now, to understand this, again we can take some examples. The example we can take is this: to convert a binary to hexadecimal form. So, let us take some number like this. If we take this, it is very easy now. This is a very easy number. What is 1101? What is its decimal equivalent? You try to find out, and that will be the hexadecimal equivalent as well. What is 1? So, write like this: 1101, this is going to be 2 power 0, this is 2 power 1, this is 2 power 2 and this is 2 power 3. What is this? 1 into 2 power 0, this is 0 into 2 power 1, this is 1 into 2 power 2 and this is going to be 1 into 2 power 3. All right. So, this gives you 1, this gives you 0, this gives you 4 and this gives you 8. So, 1101 is nothing but 13. Okay. So, it is 13, and what is 13 in hexadecimal? You cannot write 13 here, 13 will be a decimal equivalent. We have to write the hexadecimal equivalent. 13 in hexadecimal is nothing but D. So, the answer will be simply D. So, that is the hexadecimal equivalent of the binary number I have written. Now, this is a very simple one. Let us go on to the next one. Another example where I am going to take a number like this. Now, this is where we have to understand what do we mean by saying starting from the least significant bit. All right. Now, which is the least significant bit here? This is the least significant bit. And which is the most significant bit here? This is the most significant bit. All right. Now, we have to start from here and write it in groups of 4 bits. That means I should write it in which form? Look at this. I can write it like this. Now, here what do I have? I have only 1 1. This is a group of 4, whereas here you can see there are only 2 digits. I should write it also as 4 digits. How can I write it as 4 digits? All I have to do is include 2 more zeros. So, this is how I can write this particular number. Now, what is the equivalent of this? What is 110? 110 will be, as you can see, 110 will be 2 power 0, 2 power 1, 2 power 2, 2 power 3. What do you get? This will be 0 into 1, this will be 1 into 2, this will be 1 into 4 because 2 power 2 is 4, this is 0 into 8. So, what do I get here? I get 0, I get 2 here, I get 4 here, I get a 0 here. So, the answer is 6. So, this will be 6. And what is 0011? 0011 is again 2 power 0, 2 power 1, 2 power 2, 2 power 3. So, you can see this is 1 into 1, this is 1 into 2, these are all 0. So, what do I get? I get 2 plus 1, 3. This will be 1, this will be 2. Am I right? So, I will be getting 3. So, the answer is how much? The answer for this is, in hexadecimal equivalent it will be 36. We should not call it 36, it is 36 in hexadecimal unit or hexadecimal number system. Another one example that we can take up is this one, alright. We will take up this example. Suppose you have a fraction like this 1110 with a dot here. This is a binary number, we want to convert it to hexadecimal. It is very simple again. All you have to do is try to find out what is this 110 in the usual way. You should not put 2 power minus 1 and all. You write it in the usual way. This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. This is not conversion of binary to decimal number. This is conversion of binary to hexadecimal. So, what you have to write is you have to write the decimal equivalent of the number. Do not worry about the dot. So, just raise it to the power 2's. So, you will be getting a 0 here, you will be getting a 2 here because 2 power 1, you will be getting a 4 here and you will be getting a 8 here, right. And if you add up, what do you get? You get 12 plus 2, 16, alright. I mean, this is not 111, okay. What you will be getting is, this is 8, this is 4, this is 2. So, you will be getting 14, and 14 in hexadecimal is how much? It is point E, that is all. So, this is the answer for this, alright. We will take up another example, and in this example what we will do is, we will take up a number like this 0.11. See, we will take up a larger number 1011 0.11. Okay. Now, how to convert this? Here you can see I have taken both the integer part and the fractional part. I want to convert this binary number into a hexadecimal number. Okay. This is my aim. So, what should I do? I should form 4. Each number I should write it as a group of 4 digits. Here you see I can write first this side coming to the left hand side of the decimal point. I can write it as, I should start from the least significant bit. I can write it as 0 1 1 0 and then I have only a 1. So, I have to form it as a group of 4 digits. So, what can I do? I can include 3 zeros here, okay. But coming to the right hand side of the decimal point, what I can do is I have to form 4 groups, but I should now start from the first digit here, which should be my most significant bit, and go to the last. So, I should write the thing like this. This is what you should remember. If it is to the left hand side, we are starting from the least significant bit and we are forming group. After the first group is formed, if there is only a 1, put 3 zeros after that to form a group. But suppose it is to the right hand side of the decimal or the fractional, that point, binary point, then what you have to do is start from the first digit, take that as the most significant bit and write 1 1 and 0 zeros. You write the 2 zeros to follow the number. Now, you can see that this will give you, this will be 2 power 3, that will be 8, this will be 2 power 2, that will be 4, because you can see this will be 2 power 0, 2 power 1, 2 power 2, 2 power 3. Here again this 4 numbers 2 power 0, 2 power 1, 2 power 2, 2 power 3. Again these 4 numbers 2 power 0, everything should be written separately. Okay. This is how you write. Now, you can see that this gives you how much? This is 0, 0, 4 plus 8, it comes 12, right. But you should not write it as 12. How much is this? This gives us, this is 2 plus 4, 6, and this gives you just 1. So, you can see that the answer will be not 16.12, but it is 16 point, what is 12? ABC. So, this is the hexadecimal equivalent of the number that I have given. Let us summarize what we have done today. What is hexadecimal number system? We also saw how a hexadecimal number system can be converted to decimal number. Also we saw how a decimal number can be converted to hexadecimal number, all right, and we also saw how the binary numbers can be converted to hexadecimal form and so on. And also the next thing we saw was in hexadecimal number there are about 16 digits, and the 16 digits should be written as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and we should not write 10. Instead of 10 we should take the hexadecimal digits as A, 11 is written as B, 12 is written as C, 13 is written as D, and 14 is written as E, and 15 is written as F. So, these 16 digits form the hexadecimal number digits, and that is why we say that it has a base of 16. And we saw that in the conversion, in the decimal conversion we saw that we can take the hexadecimal number and multiply each digit by its weight, whereas when we convert decimal number to hexadecimal number we saw that we can take the decimal number and divide the number by 16 and collect all the remainders. Whereas, if you have a fractional part of the decimal number, what do? We multiply by 16 and collect all the carries. But when we convert a binary number to hexadecimal number, what do? We write the number in groups of 4 bits and try to find out what the decimal equivalent of the number is and write it in the hexadecimal form. This is what we did. Now, to make you understand the topic in a better way, I would like to give you some assignments. The first problem is convert the given hexadecimal number. So, I will give the number like this ECH. You convert it into a decimal number. So, when I put like this, it is a decimal number. The second problem that I am going to give you is convert a fractional hexadecimal number into its equivalent decimal number. The third one that I am going to give you is a decimal number 249. You convert it into a hexadecimal number. Then another number that I will give you is a fractional number which is 896. You convert this into an hexadecimal number. Now, having done this, I will give you another problem. The problem is conversion of a binary number. So, I will give a binary number 1101. Okay. Convert this into its hexadecimal equivalent. You take another number like this 11001110. This is a bigger number. Convert this into its hexadecimal equivalent and take a hexadecimal number and convert it into a binary number. Another problem that I would like to give you is take another number which is a decimal number and convert it into its hexadecimal equivalent. Same way, I will give you a decimal binary digit, you may convert it into hexadecimal number, and finally, I will give you another number which will be like this. Convert it into its hexadecimal equivalent. So, if you do this assignment, I think you will be familiar with what is a hexadecimal number, and you will also get familiarized with how it can be converted to a decimal number. So, also a decimal number to hexadecimal. Also, you will be familiar with how a binary number can be converted to hexadecimal and hexadecimal to a binary number. I think this lecture will be useful to you, and I also hope that you found it useful, and with this I conclude. We will continue with in my next lecture with the next topic. Thank you.